12,000 joules. Got it?
Yes, sir.
Question number 2. Do question number 2. Rima, you doing? And Alvina?
Yes, sir.
Alvina, you there? Do this one, please. Done this one?
Just a
1
second.
minute, sir.
Okay. This is very simple questions that how you can do this one. This is very simple.
Sir, is it 800?
Uh,
800.
800. Just check. We are checking it. Do it. Do let the other student do.
Sir, I'm stuck.
You stuck here in this question.
Yes, sir.
Okay. Let Alvina, you there? Alvina. Alvina, you there in the class? She's not listening. Okay, let's do this one. Just a minute. Hey, this in this question, in the second question, what we are going to do here is just a mass 10 kg is released from a height of 40 meter above the surface. Okay. I just want to know, want to clear here that when you are at the highest point, when an object is not moving, an object is placed here. So it is going to have potential energy is equals to maximum and kinetic energy will be 0 because object is not moving, so velocity is 0. When the object is start falling, okay, so suddenly its potential energy, because the height is decreasing, potential energy is mgh. Potential energy is mgh, okay, and kinetic energy is half mv square, half mv square. So as we keep on moving, as we are falling, Okay. As we are falling down, then the potential energy will decreases and the kinetic energy increases. At the bottom, at this point, we'll find that the maximum potential energy, here the kinetic energy will be zero. We'll say that, kinetic energy will be maximum, max, and potential energy will be zero. Potential energy will be equals to zero. Why it will be zero? Can you tell me why it will be zero? Because there is no height. Height is zero, so mgh, it is not above the ground, so height will be zero, so potential energy will be zero. But here at every point, the potential energy and plus kinetic energy will be equal. The sum of potential energy and kinetic energy will be equal. Okay. And what you need to mention here is that whatever the value of this potential energy, here it is. If the potential energy decreases, that for example, if we are having just understood here one thing, that let's suppose if I'm saying that there is 1000 joule energy present here. Okay, that there is 1000 joule energy at the top. Potential energy is 1000 joule. Okay, now as the object start falling down, then let's suppose at this point we are having 800 joule potential energy, and here at this point we have 200 joule kinetic energy. Then we will have 200 joule kinetic energy. Here at this point, let's suppose we have 500 joule potential energy. So here at this point, we will have 500 joule kinetic energy. At this point, we will going to have 1000 joule kinetic energy. Then the potential energy will be zero. So the sum of the total kinetic energy, that we say that total mechanical energy, always remain conserved. Okay, total potential energy always remain conserved. So we will simply say here that the total potential energy plus kinetic energy will be equals to mechanical energy at every point. At total mechanical energy at every point. Okay, so it is asking that what will be the potential energy at this point and kinetic energy, sum of the kinetic and potential energy. So it will be remain same. Whatever the potential energy is here, the sum of the kinetic energy and potential energy will be remain same. So coming to the question here on this question, what is saying here? What is it saying here? It is saying that in question number 2, the mass 10 kg. So mass is given to you, that is 10 kg. Okay, is released from a height above the ground, and the height is 40 meter above the ground. Okay, above the surface of the earth. Okay, and here g is it is saying that g is 10 meter per second square. Okay, so we need to calculate the potential energy at the highest point. Let's just calculate the potential energy at the highest point. It will be equals to mgh. That would be equals to that will be equals to mass 10 kg into, here it is 10 into height is 40. So it will be 4000 joule. So whatever the potential energy at this highest point we are going to have, that is 4000 joule, that would be equal to the kinetic energy at this point, that is equals to 4000 joule. That will be equals to kinetic energy, because here potential energy will become zero. Here we have potential energy maximum, but we will have kinetic energy will be zero because object is not moving. Okay, and at this point and every point, we will have the sum of the kinetic and potential energy will be equals to 4000. That will remain constant. If I ask you that what is the sum of the kinetic, so it is asking that calculate this mechanical energy when it is 20 meter above the ground. Let it be 20. If it is asking for the mechanical energy, the sum of kinetic and potential energy, then at this time, whether it is asking at the 10 meter, at 20 meter, at 5 meter, at 14 meter, at 50 meter, means anywhere in between these 2 points, the sum of the mechanical energy and kinetic energy will be equal to 4000 joule. Every time. Because if one thing decreases here, as we go down the group, as we go down, the height decreases, so the potential energy will decrease. Okay, as the height decreases, the potential energy will decreases, because you know that mgh, if the h is having lower value, the potential energy will decreases, and the kinetic energy will increase because the velocity of the object will increase. So as we go down the group, the potential energy will keep on decreasing and the kinetic energy will keep on increasing, but the sum of them will remain constant. It does not anywhere, at any point, it will not be greater than 4,000 or less than the 4,000. If it is 2,000, if kinetic energy is 2,000, then the potential energy will be also 2,000. Sum will be always equals to 4,000 everywhere. If it is one is 3,000, other will be 1,000. If one is 1,000, other will be 3,000. If one is 1,500, other will be 200 to 2,500. You understood now?
Yes, sir.
So just calculate it at the highest point and you will get the value. Got it? Got it?
Yes, sir.
Yes, sir.
Next, so please copy this question. Oh, just copy this question. Just a minute. Just copy the solution. That note it down that the potential energy will remain constant at every point. Okay, note it down. Potential energy is the sum of the kinetic and mechanical energy. So we can say the mechanical energy will remain conserved at every point. So the mechanical energy at the top will be equals to the mechanical energy at anywhere in between. So you can calculate mechanical energy at the top, because there the potential energy will be zero. So you just calculate at the top mechanical energy is equals to the potential energy. Do it, please.
Done, sir.
Okay. So let's move further. Let's take the next question, please. Just a minute. Do this one, please. Do this one. Done.
Give me a minute, sir.
The question number 3 is theoretical, and it is asking that what would happen when a body freed falls, its potential energy is converted into kinetic energy. But when when the freely falling body reaches the ground, it comes to rest. Okay, what happens? What happens to the kinetic energy of the body when it is stopped on the ground? So this is very simple. That the kinetic energy is converted, means it is being transferred to the earth. Okay, uh, and it is converted into potential energy. Okay, got it?
Okay, sir.
and it transfer it by using, and he means it generally means this kinetic energy is generally converted, not in the potential energy. We'll simply say that it will be converted into many types of energies, like when it is strike the ground. So this kinetic energy will be, some of the kinetic energy will convert it into the sound energy, some of them will convert it into heat energy. Okay, some will transfer its momentum. So this will, that means all the kinetic energy will be converted into different forms of energy. Got it?
Yes, sir.
Okay. Next, question number 4. Do question number 4. We have provided the solution for this one, so you can memorize the exact solution for this question number 3 from the solution. Question number 4. Do question number 4, please. A certain force is exerted for 1.2 second. Raise the speed from this to this. Okay. Later, the same force is applied for 2 seconds. Okay. The speed change in 2 seconds will be, tell me. Done. So what is saying that a certain force is exerted from for 1.2 seconds. So for 1.2 seconds we are talking about. Okay. The force is applied and we don't know what amount the force is, but it is a constant force. And time is taken that it is applied for 1.2 seconds only. And then it changed the speed of an object from 1.2 meter, which is initial velocity is 1.8 meter per second, to final velocity is 4.2 meter per second. Okay. So you know that we have three equation of motion. V is equals to u plus at. S is equals to ut plus half at square. And uh, v square is equals to u square plus 2as. Okay. In all the three equation, one is common, that we have the initial velocity. In everyone, we need the initial velocity, and everyone is having the a acceleration. Okay. So it is saying that certain force, and it is asking that how much does the speed change in 2 seconds. So it is asking that a certain force is applied on an object for only 1.2 seconds, then it changes speed from 1.8 meter per second uh, to 4.2 meter per second. It's the same force. Let us the same force is applied for 2 seconds, means the same force is applied for the next 2 seconds. Then how much the speed will change in 2 seconds? So how will you answer? But it is not saying for the next. Later, the same force is applied for 2 seconds. So instead of 1.2 second, if the speed, if the same force is exerted for 2 seconds, then how much the speed is changed? Tell me. So it is asking for the next 2 seconds. It should be for next 2 seconds. Next 2 seconds should be there, no? First of all, calculate the acceleration here. Calculate the value of a. V minus u by t. Are
0.
you doing?
Yes, sir.
So what is the value of a?
I got 0.4.
Why 0.4? It is applied for the v. A is equals to is being given to you, na? So v is given to you 4.2 minus 1.8 upon 1.2. So you subtract it, what you will get? 12 minus 8 is 4, and 3 minus 2.4 you will get upon 1.2. When you cut it, you will get 2 meter per second square. Okay. Got it?
Mm. Yes, sir.
Yes.
So it is asking if the same force. Now the force is applied for the next 2 seconds. Then how much speed will change? Tell me. Tell me. This is very simple question. A is equals to V minus U by T. Just multiply it. It is asking the change in speed. So V minus U is the change in speed. So A into T is equals to V minus U, and V minus U is actually change in speed. Change in speed. So just multiplied it. A is, you have calculated 2 and it is asking for the next 2 seconds. So it will be V minus U is the change in speed. Change in speed will be 4 meter per second. Got it?
Yes, sir.
That will be equals to 4 meter per second. Next, just a minute. Now tell me, can two forces acting in perpendicular direction be balanced? If the two forces is like this, if one force is like this and they are acting perpendicular to each other, can it be balanced? No, they cannot be, na? Is it possible that you are having a let's suppose you are having a matchstick. Okay. And a person is applying a force on this one. So is it possible that this stick will not rotate? It will rotate, na?
Yes.
Or will you able to rotate it? Means if you are just applying a force in this direction and someone is applying the force in this direction, will it not? Let's suppose you are having a book, like you are having a book here, like this way. You are applying the force in this direction, and another person is having book here, here, another book, okay, and he is applying the force in this direction. So will this book not move in this direction? You are applying the force in this direction, he is applying the force in this direction, the book will move in this direction. Okay, so it is not possible they will cancel it. It is the possibility for cancelling out each other will be only when they are having the opposite direction. Like one force is applied in this one and the another force is applying with the same force and in the opposite direction. If it is 5 Newton, so it will be also 5 Newton. Then they will cancel out each other. Okay, got it?
Sir.
Otherwise they will not cancel out each other. So it is written in the solution. Okay, written in the solution. Next, the distance time graph of a moving body is shown in the figure. What is the conclusions can you draw about the just a minute, we have not taken the whole question. Here we have. So tell me, what is said here? Tell me. The distance time graph of a moving body is shown in the figure as it is shown, distance time graph. What conclusion do you draw? What is it? Is it an accelerated body, accelerated motion or not? Is the force acting on a body? Tell me. Tell me. Are you? You're not answering. Alvina?
Sir, it's the acceleration of the body.
Yeah, there will be, this is then considered to be as an accelerated motion. Why?
Uh, because
Here you will see that firstly, its speed, its distance is increasing with time, and then it stops. So then it is stopping now. Means with time it is when the time is constant, time is increasing, but the distance is not increasing. That it is 100 meter here, so it will remain 100 meter. Time keep on moving, but it will remain 100. So here you see that it is not. So it is retarding. Means it is stopping. It is applying the brake. And whether we are not asking that it is applying the brake or not, we are just asking that if it is an accelerated motion. Retardation is also a negative acceleration. So it is asking is it an accelerated motion? Yes, it is an accelerated motion. Only in distance time graph, if we have distance, this is the distance and this is the time graph. If it is moving like a straight line like this way, so it will be considered as uniform motion. Okay. And when there is a uniform motion, means no change in the speed is taking place. No change in the speed is there. Speed take place. Okay. And if there is no change, means v minus u is same. If it is initial 50, final is also 50 meter per second. So you see that if you keep this value as 0, the 0 by t will be equals to 0, so acceleration will be 0. So if it is like this graph, a straight line in distance time graph, then it will be a zero accelerated motion, or we can say that it is not having any acceleration. But if we have any graph like this, like like the distance is increasing, but with time it become constant. Means here the object stops. With time it is not increasing. You see that from this to this the time is increasing, but the distance is not increasing. So it is considered to be as uniformly, we can say that it is retarding motion. Okay. So acceleration is applied. Yes, it is uniformly retarded motion. Uniformly retarded motion. Retarded motion. And you know that force is applied. Yes, force is applied in the opposite direction of the motion. So if the car is moving, when the brake is applied, then it will be opposite to the direction of motion. Yes. There is an acceleration, we will simply say that if there is an acceleration, simply means that retardation means force is acting, because you know that F is equals to m into a and mass will be there. So if there is a, whether it is a negative a or positive a, let it be, but it is a, acceleration is there, so it is having force. So we will say yes, the force is acting. Yes, the force is acting. And you know that since the acceleration retarding means when the brake is applied, acceleration is taken as negative. So we will say that F is equals to minus A. So F is equals to minus M into A. So here the force will come negative just because here the negative sign indicate opposite. That for example, if the car is moving in this direction, okay, if the car is moving in this direction, then if you apply the brake, it will move opposite to this direction. This is just simple. Got it?
Yes, sir.
Okay. So a negative sign indicate the opposite direction. Next question. Let's take the next question. Tell me this one. Block of mass 3 kg start from rest and slide down a curved path in the shape of a quarter of a circle of radius 2 meter. Okay. A block of mass 3 kg. So how will you solve this one? A block of mass 3 kg start from rest and slide down a curved path in the shape of quarter of a. So how will you solve this question? Please tell me. Read this question carefully, everybody. Riaz, Abdul Jabbar, Reema, Nabila, Rumaisa, Alvina. Are you getting the previous questions? Tell me honestly.
Yes, sir.
Sure?
Yes, sir.
Yes, sir.
Okay. Do this one, please. Are you doing?
Yes, sir.
A block of mass 3 kg slides. Just imagine that it is a block of mass 3 kg, slides a curved path in the shape of a quarter of a circle. Quarter of a circle. So it is like a quarter. Quarter of a circle is like this. Okay, this is the quarter of a circle. So it is a block here placed and it is just sliding downward like this way and comes like this way. Okay, slides down in the path of a quarter of circle of radius 2 meters. So radius is 2 meter. Here is also 2 meter. Got it? It reaches the bottom of the path with a speed of 4. Now, when it touches bottom of the path, when it touches, so it reaches with a speed of, so velocity is given to you 4 meter per second and G is given to you 10 meter per second square. Okay. What is the amount of work done by the friction force? So amount of work done it is asking to stop it. Okay. So tell me, what is the amount of work done by the friction force?
60 joule
You know that,
mgh.
yeah, 62
60.
joules,
No, 60.
60 joules. Okay, let's check.
Sir, 240 joule.
240 joules. Okay, let's check. You will simply calculate the final velocity. Okay. There are so many ways to solve this question. So it is saying 4 meter per second. So initial velocity, a block of mass 3 kg from rest. So U is 0. So it will be half mv square. You can use formula. Half into mass. How much mass is?
3.
3 kg. And V is 4 into 4. So it will be, you cut it by 2, you will get 3 2s are 6, 6 4s are 24 joules. Okay. This is the one type of answer. The second answer, tell me. mgh. Mass is 3 into G is 10. H is and it slides down.
Sir, H is 2, right?
Yeah, H is 2. We will consider H as 2. But if we take like work done is equals to force into displacement. Force is M into G into S. If we took the distance, displacement, that would be 2 root 2, that would be much greater. A block of mass 3 kg start from rest and slide down the curved path in the shape of a quarter of a circle of radius 2 meter. Good. And reaches the bottom with a 4 meter per second. If G is equals to 10, then what is the amount of work done by the friction? So you know that this object start from rest, okay, and here it is having the energy that is so it is independent on the, it means kinetic energy we can calculate, it can be 24 joules. Got it?
Yes, sir.
But 24 joule is the energy that is the kinetic energy. Okay, now you calculate the another energy, that is mgh. Calculated the another energy, but because you know that it is going to have how much potential energy it is going to have right now. Okay, so calculate it please. That would be mass. You know that it is independent. Let's you understood this. This is very important questions according to your concept. Please understood this one. Okay. In this question, it is being said. Just a minute. Let me record this question because this is an important for the examination point of view. Yeah. Now, this is this questions you need to understood here, and this is an important question, that it is being said to you that when an object is moving in a circular path, okay, semi in the portion of the quarter of the circle, okay. Now you see that we have calculated its potential energy, sorry, kinetic energy at this point. At this point, when it is having the 4 meter per second, it must have the greater speed. It must have the greater speed, but due to friction, its speed is only having 4 meter per second. So it is said that a block of mass 3 kg, the mass of the block is 3 kg here, and its final velocity when it reaches the ground is 4 meter per second. So we just calculated it is 24 joules only. Got it? 24 joules. But you know that the potential energy is always independent on the path taken. It is independent on the path taken. You understood what I am saying? It is independent on the path taken. So if you are having, suppose if you are having an object and you need to carry it from here to here, okay, you can take it by lift like this way. You can take it by rolling, by anything. If you need to calculate the potential energy, it will be equals to m into g into h, this height. So you know that the object here, the object whether it is placed here or here, the height from the ground will be 2 meter. Got it? The height of the ground will be 2 meters. So actual potential energy that it is going to have here is how much potential energy it is going to have at this point. So we will calculate it. It is mgh. Got it? And that would be equals to mass. How much mass? 3 kg. Okay. And gravity is 10 and height is 2 meter. So how much it is? 60 joules.
Yes, sir.
Okay. Now now you know that at this point this is having 60 joule. So at this point the potential energy will be 0, but the kinetic energy will be 60 joule, because you know that when an object start traveling from upside down, then at the point of contact, it is going to have, means all the kind potential energy that it is going to have at this point A, and that B is the point of contact. Then at the point B, all the kinetic energy will be converted into potential energy. You understood?
Yes, sir.
Oh, sorry, all the potential energy will be converted into kinetic energy.
Okay,
Okay.
sir.
Now it must have at this point, it must have 60 joule energy, but it is only having 24. other energy is being lost due to friction. So the lost energy is the lost energy by friction, friction that is equals to 60 joule minus 24 joule. And that would be equals to 60 minus 24. How much you will get? 36. So 36 joules has been utilized by this one. You understood this question? Or should I
Yes, sir.
explain you one more time? Is there anyone in the class that who didn't understood this question? Rima, you understood this question?
Yes, sir.
Alvina, Nabila,
Yes, sir.
Sir, is it like a sure question? It will come for exam?
what are you asking?
This question, is it a sure question?
Yeah, this means these are the important questions that we have to take, and this will build up your brain that how you are going to solve the question. The examinations is not going to have this level of question, but this will increase your ability to think that how and what is happening here. Okay, what is happening here?
Yeah, okay, sir.
So what we are going to do is what we understood in this question is just simple that object. There are two laws that we have studied, that potential energy is independent of the path taken. If the object is traveling like this way, okay, object is traveling like this way, or whether you drop it like this way. Okay, if the object is traveling like this way in a semicircular path of 2 meter, so here it is also 2 meter, so the height is 2 meter. So whether you drop it like this way or whether it comes like this way, the change in the potential energy will be same. So if the object is placed like this way and it goes like this way, the height here it is going to have how much potential energy? That is mgh. M is 3, G is 10, and height is 2 meter. This height will be considered as a perpendicular height, okay? Height. So it is 2 meters. So it will be 60 joule. But you know that in the question, it is saying that it is moving like this way. It is moving like this way. Okay. So here it is saying that it is start from rest. And since it is starting from rest, then because you know that when it is starting from rest, its initial kinetic energy will be 0 because initial velocity is 0. At rest means 0 velocity. When it comes down, it is having only 4 meter per second speed. Okay, 4 meter per second. So you can calculate that half mv square will be equals to half into mass is 3 into v square means 4 square. Okay, that you cut it, you'll get 2, and 2 3 are 6, 6 4 are 24. So 24 joule we are having this kinetic energy. Now you know that if you have freely fallen this object, if you have, because there is, you know, this object is coming with the surface in contact, okay, so there must be some friction which is reducing its speed. If this object is freely fallen from here, then it must not have that speed. How much speed it must have? Let me calculate that. It must have how much speed? So it must have half mv square, because you know that kinetic energy will be exactly equals to its potential energy point, because this at this point potential energy will become 0 and the whole 60 joule energy will be converted into kinetic energy. So we will say that at this point of contact, the kinetic energy will be 60 joule. Here the potential energy is 60 joule and kinetic energy is 0 at this point. But here kinetic energy will be 60 joule and potential energy will be 0. So you can calculate that it would be half into 3 into v square, you need to calculate, into 60. Okay, and then this 60 will goes down and this 3 will comes down. So you will see that v square will be equals to 60 into 2 upon 3. This 2 will go to that side and this 3 will comes down. You get it? You will get 2 and you will get 40. Okay, and v square is 40. V square is 40. Okay, v square is 40 and 40 is near the root of 7 and 6, means you know that if you do the square of 6 you will get 36, and 40 and the square of 7 is 49. So this is 40, so it is lying for means v will be approximately 6.5 or something, but it is only having 4 meter per second speed. It means its speed is being reduced. So this reducing speed is reduced by, means this speed is reduced, that is only having 40, but it should have accordingly 6.5 meter per second. If this object is freely fallen, then it must have the speed of 6 point something. Okay, but it is having only 4 because it is sliding. and its surface is in the contact with this one, and that's why it is sliding, and this why it is reduced. So that how much energy it is only having, at this point it is having 24 joule, but it must have 60 joule here. So the 36 joule of energy is being eaten up by the friction. Okay, you understood now? Understood?
Sir,
Yes, sir.
Is there anyone who didn't get this one? Let's take the next question, please. Let's take the next question. Question number 8. Okay, tell me what's the answer for this question. Solve this one, please. Done.
sir, is it 42 joules?
Is it 42 joules? Let's do. The figure of acceleration is being set to you here. This is the figure. Okay, and as the body moves from along the x-axis, from rest along the x-axis, means it is traveling from the rest along the x-axis. Variable force act from x to 9 meter. It is being given to you. Find the work done by the force on the body when it reaches for the first 4 meters, and then the 7 meters. Okay, 7 meter distance. So you know that this is acceleration versus displacement time graph. Here it is acceleration and this is meter. So it is acceleration versus displacement. So you know the what is acceleration unit? Acceleration unit is meter per second square. So you can write it like this way. Okay, into meter. Displacement is meter. So it will be meter square upon second square. Got it? Got it? Meter per second square is, so area under acceleration, if I talk about, okay, so it will gives you speed. So what is it asking? No, the find the work done by the force on the body when it reaches to this one. So how will you find out this one? So it is saying that acceleration first, for the 1 second it increases from 0 to 6 and then remain constant and then decreases. So it is asking for the first 4 meter, acceleration is equals to, means initially it is 0. Okay, so you need to calculate here and then this portion. Got it? So here it is saying the figure give the acceleration of 2 kg. The mass, just write down the biography of the question first. Mass is 2 kg. Okay. Mass is 2 kg as it moves from rest along the x-axis. While the variable force act on it from 0 to x is equals to 9. Find the work done by the force force on the body when it reaches from x is equals to 4 meter and x is equals to 7 meter. So work done by the force निकालना. So you know that force is equals to m into a, and work done by the force is force into displacement. So you can write it m into a into s. Mass is 2 kg. You know acceleration. Okay. Are you talking? Are you there?
Yes, sir.
So here the force is acting constantly from 1 to 4 seconds. Okay, in this portion. Just took it. In this portion, here the acceleration is 6 meter per second square. But here you see that the acceleration is changing with time. In the 0 to, from 0 to 1 second, it is changing. It is start from 0 and then it is, means the object is stationary. Okay. So here and then after for the 4 second, it remain constant. Got it? Got it?
Yes, sir.
Now we need to find out that acceleration into displacement is what it is going to give you. It is give you meter per second square, meter square per second square. So just calculate it for the first from 1 to 4, how much it is going to force is going to act. The work done is equals to mass is 2 kg and acceleration is 6, because it is having 6 meter per second square up to 4 seconds. Okay, into acceleration into displacement is 4 meter. But here you see that we will take only 3 meter here because we are just calculating the here of this part only. Got it?
Yes,
Are you getting my point?
yes, sir.
And this will gives you 2 into 6 into 2 into 6 into s is 4, but we will not write 4 here because we know that we have not taken it from 0, we have taken it from 1, 2, 3, 4. Okay, so we'll write here 3. So that would be equals to how much work done? Tell me. 2 3 is 6, 6 3 is 18 joule. Sorry, 6 to the 12, 12 is 36 joule. Sorry, 36 joule. So 36 joule is the work done for this value. Okay, got it? So what you see here, that did you notice one thing here, that work done here, if I have a box like this, okay, and it is having this dimension 6 and 3. Okay, got it?
Yes, sir.
So area under this box, what you are getting is 6 3 is 18, and then you have to multiply it with constant term, that is mass. So we can say that mass acceleration into displacement give the acceleration. Just this is very important. Let me explain you. This is very important question. Just concentrate everywhere. Everyone, please concentrate here. This is the graphical questions, and this type of questions, let's understood that. For example, I'm having displacement time graph. Displacement time graph. Okay. If I'm having this, let this graph, if I'm having this graph, okay, like this way. Okay. And if I ask you that this is displacement time graph, what is the area under this graph will gives you? What is the area under this graph will gives you? Area under this graph. So just multiply the unit of this one and this one. Whatever the value you get, you will get the value. So here you see that displacement and time graph. Displacement has unit meter and time is unit having seconds. Unit seconds. Okay. Displacement is having meter and time is having unit seconds. Got it? So in this case, meter second is not means anything is meter second is not a unit of any physical quantity. You see that meter per second is for the acceleration. Okay, and we have meter per second. We have meter per second is square, but meter second is nothing. So area under displacement time graph will give you nothing. Let's take the another example. Let's take the example of displacement time graph. Sorry, velocity time graph. Velocity time graph. Okay, velocity time. Now I'm just making this graph. Okay. And if I ask you that what would be the area under this graph will gives you. What will be the area under this graphs will gives you. So just calculate, just multiply these two units. The multiply the unit of y-axis and x-axis, and whatever the value unit you will get, this will give you the same thing. So the you know that the meter per second is the unit for the velocity, and time we have seconds. So multiply meter upon second into second. Meter per second means meter upon second is for the velocity unit, and time is second. So you cut it, you will get meter. And now you know the meter is the unit for the displacement. So area under VT graph will give you displacement. Area under VT graph will gives you displacement. Now just coming to the point here for the next one. Now just coming to the point. If we have acceleration time graph, like we have acceleration time graph. Okay, and if I ask you that what would be the area under acceleration time graph will gives you. Acceleration time graph, what will be the area under acceleration time graph will gives you. So you know that this is an acceleration and this is time. So you know that acceleration is having unit meter upon second square. And time is, sorry, it is not acceleration time graph that we were having in the question. It is acceleration displacement. Here is x is in meter. So it is displacement. So if I ask you that acceleration, what the area under acceleration and displacement time graph will gives you. So just multiply these units. The unit of y-axis is meter upon second square, and the unit of displacement is seconds. Sorry, meter. Okay. Now you know that we will get a unit of meter square upon second square. Now you will get confused, sir. We have meter per second square as a unit. We have displacement. We have meter per second as a unit, but we don't have anything meter square upon second square. We either have meter per second square, we have meter per second. This is for acceleration, this is for speed, but we don't have any unit meter square upon second square. Okay, so you know that this is actually the unit for the acceleration, and this is meter is the unit for the displacement. And you know that acceleration into displacement, what it will gives you? It will gives you, you know that work done. Now just come to the point. Acceleration into displacement, what it will gives you? You know that force is equals to mass into acceleration. Force is equals to mass into acceleration. And you need to calculate the work done. Okay. So work done is equals to mass into acceleration into displacement. Just you have calculated that this value, acceleration into displacement has a unit meter square upon second square. You can check it, meter per second square for the acceleration, and displacement is meter. You will get meter square upon second square. So this acceleration into displacement has a unit of this one. Means this make a this different physical quantity A into S, any acceleration to displacement. So in the, if you get the area, like now I'm going to get the area. I'm going to take the previous question here. Okay, let's take the question here. Here in this question, it is asking in this question, just concentrate here just for 2 more minutes. It is asking that calculate the work done by the force. Calculate the work done by the force when it reaches. Okay. Calculate the work done by the force when it reaches from 4 meter at the 4 meter. So just you need to calculate the area of this one. Area of this whole body. This triangle plus this one, or you can consider it as a trapezium like this. Okay, so this is going to have here you have unit. This height is 6. This is 6 units. So the height is 6 meter. Okay, and here to here is 4 meter. Okay, 0 to 4. Now calculate the area of this trapezium. This trapezium will gives you the unit as the same unit of acceleration into displacement. So you will get the area. So what you will going to get, the area of trapezium is half into sum of the non-parallel side. So it is 4 meter, and this one is 3 meter. Here you know this is 4 meter, but it is 1 meter less. So it is 3 meter. Sum of the non-parallel sides plus into perpendicular distance between them, this is 6. You cut it, you will get 3. and this will be 7 into 3. It will be equals to 21 units. Okay. So now this you get the 21 units. 21 unit is the value of, you get the area, and it is the value of meter square into second square, means which is equals to area into displacement. Now you need to calculate the work done. You know work done is equals to mass into area into displacement. Now you have calculated area into displacement as 21. Just multiply this with mass. Mass is 2 kg. Just multiply it by 2 and you will get the answer. Got it? Got it?
Yes, sir.
So we will discuss this one in the next class also, and because this is new questions, we will send you the particular video for these questions. Okay, so just concentrate on these questions. Okay, that's all for today. You can leave the class. Okay.
Okay, sir. Thank you, sir. Bye.
Thank you, sir. Bye. Take care.
Thank you, sir.